Hello and welcome to video 29 in my Rigging in Maya series. We now have a basic spline IK based spine, but there's still a lot of work to do on it. So in this video we will add those finishing touches. These will include squash and stretch, advanced options for the middle of the spine, and also a quick update so we can change the curvature of the spine. We'll also make the legs follow the spine too. Before we dive in, I wanted to let you know that you can now download all the source files and the scripts for this and all my other courses from my CubeBrush, Coffee, Gumroad and ArtStation pages. You can find links on the screen and in the description below so you can follow along and pick the files apart to see how they work. While we're here, I may as well mention the antCGi Club. Becoming a member of the club is your way of helping to support more content in the future. Be these free videos, assets, or just help and advice. Memberships start from as little as 99p a month, and in return you can also earn yourself exclusive rewards. These include course assets, models, rigs, and custom-made scripts, as well as a limited edition antCGi pin badge. What's more, you can also claim a discount on all antCGi merchandise at my Teespring store. There are two ways you can join. The first is to simply click on the join button below this video and become a member of this YouTube channel. The second is to head over to my Patreon page and support me there. Alternatively, you can visit the link on the screen or in the description below to find out more. Okay, so here we are, exactly where we left off in the previous video. We can move and twist the controls, and they drive the spine ribbon. The problem is, if we move away from the ribbon, it doesn't follow. If we pull the opposite end, the whole spine moves away. So we need to fix this. What we're going to do is make the spine stretchy. This will ensure the ends stay where they are no matter what the opposite end is doing. And for this particular area, it's quick and easy to set up. Okay, let's open the node editor. Previously, we used distance nodes to help determine when the limbs were stretching. We then used that information to scale the actual joints. We could do the same here, but this time we're going to use a different approach. Bring the spine curve into the node editor. All we need is a shape node, so let's remove everything else. We need a new node now, so create a curve info node. What this will do is feed back lots of detailed information about a connected curve. Okay, rename this to spine curve info. Now connect the curve shape's world space 0 attribute to the curve info node. Just select other, and let's update the view so we can see the attributes. There we go. We need the input curve attribute. If we look in the attribute editor now, we can see all of these details. The only one we are interested in is the arc length one here. This tells us how long the curve is, and it updates as the curve stretches. So we can use this to tell us when to stretch the actual joints. Okay, now create a multiply divide node. And let's call this spine stretch factor. So we need the arc length. Connect that to input 1x. Now copy that value and store it in input 2x, just below it here. We need to store it so we know what length the curve is when it isn't stretching. The multiply divide node will compare these values for us. If we change the operation to divide, it will divide input 1x by input 2x and currently return a value of 1. When the scale changes, this value will increase or decrease depending on the length of the curve. so this is perfect to use in our joint scale attributes, simply because we need those to have a default value of 1. All we need to do now is connect these to our driver joints. Open the connection editor, load the multiply divide node into the left side, and open the output attributes. We want output X because that is the result of our stretch check. Now select and bring the driver joints into the connection editor too. You don't need to do the shoulder joint at this stage because the stretch will only affect the area after each joint. Let's change the options so we can focus on the main attributes. And open the scale ones. Now simply connect output X to each joint scale X attribute. This is the axis which points towards the next joint. That's changed to yellow to indicate it's connected. Let's see if this has worked. So now I can move the shoulder control and the spine stays locked to it, and it stretches. I can also move the lower spine and the shoulders stay where they are. The same happens if we move the middle control. The end stays locked. So we now have a stretchy spine, which for a dog or a cat is ideal, as we need to have as much flexibility as possible, so they can get into those impossible positions. One important thing I need to mention, which I forgot to record in this part of the video, is that you also need to connect the output X attribute from the scale factor node to the ribbon joints too. These are the joints that are going to deform the model, so they need to scale as well, so the model deforms correctly. I actually think I also skipped this when I built the legs, so I'm going to go through and make sure those are all updated too before the next video. Okay, so now we have the spine moving, we need to get the legs to follow it. This is quite easy because we already built controls which move the upper ends of each limb. Let's look at the lower spine first. So we need to find these controls first. What we need are the offset groups. All we're going to do is simply use a parent constraint to constrain these to the control. What we don't want though are the rotations, so let's disable those. Now let's do the right leg. We can now move this control and the legs follow. Let's hide some of these systems. Okay, that works nicely. You see, if we rotate it, the legs still follow but maintain their own orientation. This is why I disabled the rotate option, so the upper legs don't rotate too. This approach is a much more natural way to animate, and it gives the animator more freedom. We also opted for a parent constraint instead of a point constraint, so the legs actually move as if they're parented as the lower spine control rotates. Okay, let's do the front legs. So we actually need to do a bit more work here because we didn't add any controls for the scapular joints. I have a couple here which I already added and positioned. I'm not going to go through this process again because I've covered it plenty of times before. I also made sure their orientations matched the joints too. So we just parent constrained these to the joints, with rotation added too. That's one. And that's the other one done. Now we want these controls to affect the main leg controls. There are lots of different options on how you can do this. You could maybe use constraints and have some sort of space swapping system, so you have more control. To be honest though, I find simply parenting the leg controls to the scapular controls works well enough. There's no point in overcomplicating a rig if it doesn't need it. So let's find those leg controls and move the scapular offset groups to the leg groups. Now parent the leg root offset groups to the scapular controls. The leg now follows as the scapula moves. Okay, let's update the other side. That's done. Now all we need to do is parent constrain the scapular offset groups to the shoulder control. Remember to disable rotate. There we go. The legs now follow the spine. So we are starting to feel like this is approaching a more complete rig. One thing I also wanted to point out is that because we are using a ribbon, we have all the options open to us to also deform it in any way we want. Obviously, we have the main controls which will move, bend and twist it. But like with the legs, we could also use a blend shape. Remember, the ribbon joints are what's important here. I'll quickly demonstrate. So let's duplicate the ribbon and unlock it so we can move it. Let's throw on a very quick blend shape. And also set that to 1 to activate it. So if we deform this now, the ribbon follows and so do the ribbon joints. You can use this method to achieve more poses with the spine if needed. Or as we did with the legs, apply a sine or twist deformer for more flexibility. You could even add a jiggle deformer to add that extra secondary animation that we also added into the legs. So we can move the shoulder control now, and the lower spine control. We can also use the spine control to move the whole body. The problem we have now is the middle control. It's kind of just floating in the middle here. If we move the other controls, it doesn't follow, so this will mean more work for the animator. It's difficult to choose what to do with this control. Should it follow the shoulder control or the lower spine? Maybe it should just stay floating between them. In these instances, I prefer to give the animator the choice of what it should do. Yes, it's more likely it will just need to stay between the other controls, but there will be animations or poses where it shouldn't. So let's create a system now where the animator has control over what the middle control does. What we need to do is create a space swapping network, so the control can move between the different options. One of the options will be to stay in world space, so like it is now, so we need something for it to anchor to. We can use a locator for this, and this will be used when we set up space swapping on other controls in the future. So let's create a locator. Make it bigger. And rename it to World Space Position Locator. And I'm just going to parent it to the root control. This is so it follows the character, so the world root is relative to the character rather than the actual world. Now let's create an attribute so we can control what the control follows. Let's call it follow and set it to be an enum. Now change the names in the list. We need both to follow both the shoulder and lower spine control, then shoulder to just follow the shoulder control, root to stick to the lower spine, and finally world. Let's add that. Close this. We now need a parent constraint, but we are going to constrain the offset group on the control. Select the lower spine control, and then the shoulder control, and then add the world space locator. Now add the mid-spine offset group. Now create a parent constraint with the default options, so maintain offset is enabled. Here is a constraint, and here are the 3 weight options, so we can use these to control how the middle spine control works. If we set upper spine and world space position to 0, you see, the control follows the lower spine control. If we set upper spine to 1 instead, it now follows this control. And finally, if we set world space to 1, it will obviously ignore the other controls and follow the locator. Okay, so now we need to wire up the controls. You could use set-driven keys to do this if you prefer, but I find nodes are more efficient and also offer more control and flexibility. Let's open the node editor again. And bring in the mid-spine control. Remove the shape node, and now add the parent constraint node. Open these up. You can just press 3 to do this. So there we have the follow control. And we have the weight attributes here. Okay, to start us off, we need a condition node. We're using these because we can simply check what the follow attribute is set to and update the corresponding attributes. Let's call this follow both condition. And open it up. Duplicate this 3 more times and rename them. So follow shoulder, follow root, and follow world. Okay, those are set. What we need to do is not only set each weight value to 1 when the follow attribute asks for it, but also check for when both is active, and then set the shoulder and lower spine weights to 1 instead. So this is a little fiddly to set up, but I'll try my best to explain as we go. Start by connecting the follow attribute to each first term attribute. Let's look in the attribute editor. So the first term will change depending on what follow is set to, and the labels we created will be represented by a number. It's now set to both, which is first in the list, so is equal to 0. Shoulder will be 1, root will be 2, and world will be 3. If we set it to shoulder, you can see first term is now 1. And root is 2. Okay, let's set it back to both. So we can use the second term to check if it's equal to the first term. So when first term is set to 0, we do something. So if it's 0, we use the colour if true value here. If it isn't 0, use the colour if false value here. So let's update these values. We need the true values to be 1, so the weight is set to 1. And the false ones need to be 0, so the weight is then set to 0 and switched off. I'm only updating the first two here because the third column will be used later. These values are then output through the outColour attributes. So first connect outColour R to the upper spine weight. This is the output from the first column in the condition node. Now connect outColour G to the lower spine weight attribute. This is the output from the second column. Now connect outColour B, which is the third column, to the world space attribute. So you can see that the three outColour attributes now control the weights. With the follow attribute set to both, the control now follows both controls. But we have more to do to get this working properly. Go back to the node editor, and let's look at the shoulder condition node. This time we want the node to be true if the first term equals 1, so the attribute is set to shoulders. If it's true, set the weight to 1. If it's false, set it to 0. For these nodes, we are only interested in the first column. Now connect outColour R from this node to colour if false R on the original condition node. So you see, we can control the attributes on the original node, depending on what the main follow attribute is set to. So if the first term here is not set to 0, then we don't want to follow both controls. So in this instance, the condition node checks the colour if false attribute. This now changes if the follow attribute is set to shoulder, so it's triggered. Let's do the root or lower spine control next. Select the root condition node. Set second term to 2 so it triggers when follow is set to root. Colour if true is set to 1 here, so the weight will be set to 1. And false is set to 0. Now connect outColour R to colour if false G this time. Finally, let's wire up world. So set second term to 3. And colour if true to 1. And false to 0. Now connect outColour R from this node to colour if false B. So there we have the three main attributes piped in. Also make sure colour if true B here is set to 0. We don't want this triggered here or the world space weight will be 1 when we don't want it to be. Okay, let's test it. If we set follow to both, it should float between the upper and lower spine controls. Great, that works. Perfect. Shoulders should just follow the shoulder control. Root will stick to the lower spine control. And world doesn't follow any. So this setup will be good if you need to pin the chest to the floor for any reason. To be honest though, most of the time this will be set to both, but it just gives the animator more options and more flexibility. And this kind of setup can be used anywhere, so feel free to add it to other elements of the rig if you need it. So there's one more thing I wanted to show you, which is quite a nice bonus feature which comes from the way we set up the spine. Because we used joints to deform the curve, we can also scale them to change the curvature of the spine. So if I scale the control joint here, you see we can curve the back more, or make it more angular. So we can add this into the rig. Let's create a quick attribute on the control. Set the default value to 1 because all our scale values default to 1. And let's call this Bezier curve. And add that now. Now connect that attribute to the control joint's scale X attribute. Simple as that. Now it's an easy step, but it adds more flexibility to the spine. We can do the same with the upper spine too. And the lower spine. So let's add those attributes to these. And wire them up. That's one. And the other. Let's test them now. Okay, so there are points where this will break the rig, so it's not perfect. The same here when we go past a certain point. What we can do though is lock these attributes so the animator never actually reaches these values. So let's edit the attributes, and we can set a minimum and maximum value. Let's set the maximum to 2. So this is locked now and won't break. Let's try 5. Maybe 3. Okay, let's do the same with the other control. This was more prone to breaking. Let's use 0 and 3 again. With these being connected to scale values, we don't want them to scale lower than 0. Okay, that works. Now the upper spine. Okay, we get this slight issue here, so let's try a minimum of 0.1 instead. That's better. Okay, so feel free to experiment more with these as you may want different values. Okay, let's reset these. So that is a spine setup, and we can do exactly the same to rig the dog's neck. So I'm going to pause the video here and I'm going to go through and create the neck, and I will be back in a minute. Okay, here we go. The neck is now rigged in pretty much the same way we did the spine, using a blend of spline IK and a ribbon. Let's hide the model. So you can see the ribbon here, which is the same as the spine, just a smaller one with fewer joints. It has the same spline IK handle, The control in the middle is simpler as it just stays between the shoulder control and the head control, using a parent constraint. We have the same twist setup. As you can see, we can move and stretch the neck too, and twist it. What I also did with this scene is update the ribbon joints, so the scaling is connected to these two, and I mentioned this earlier in the video. And on the neck too. Also the legs, so everything is updated now. So on the head I added two new attributes, follow shoulders and orient shoulders. Let's quickly skin the model so you can see it working better. Okay, that's working. So I can rotate the shoulders and the head follows. We can adjust the neck and the head, and the neck stretches. You see, we get a nicer stretch in the spine now we connected the stretch to the ribbon joints. Okay, back to those attributes. At the moment, follow shoulders is set to 1, so the head is being told to follow where the shoulders move to. Orient shoulders is set to 0, so the head shouldn't rotate with it. Okay, I can see the joints are doing what I want, but the head model isn't. Let's reskin it, but add in some of the head joints too. That's better. So the head is staying level, but moving with the shoulders. Let's just hide those eyes. If I set orient shoulders to 1 now, the head will tilt to match the shoulders rotation. If both are set to 0, the head stays where it is. So all this is just two parent constraint nodes. One just using transforms and the other just using the rotations. So we can control both independently. And we just use a reverse node to blend between the upper spine control and the world space locator. I've covered this plenty of times before in this series, so this is nothing new. Let's open the network. So you see we have both weights here, one driving translations and the other rotations. Feel free to download the source files and take a closer look at this setup. Another option, which is something I'm still experimenting with, is to use ribbons with the jiggle deformers like I showed you with the legs, to add some muscle simulation to the chest and stomach. Something like this. Like I say, I'm still playing with that for now, so I may pick it up in a future video. If not, it will certainly be included in the source files. Okay, so we're getting closer to a fully rigged dog now, minus the paws and the head. I think in the next video we will look at rigging the tail using a blend of IK, FK and also dynamics to drive it, and we can also use the same setup in the ears. Well, we've come to the end of another video. Thanks for watching right to the end, and if you found this video useful, please hit that like button to show your support. While you're at it, you could also subscribe and enable notifications so you are kept up to date with future videos and community posts. If you have any questions or suggestions, please post them in the comments below, or alternatively, why not join the antCGi community Discord group, where me or other members of the community will be more than happy to help. Remember, to help support future content and keep these videos free, why not join the antCGi club and earn yourself some exclusive rewards. Alternatively, if you would just like to show your appreciation for these videos, why not treat me to a coffee at my coffee page? The link is on the screen now and in the description below. Thanks again, this is antCGi signing off, and I will see you on the next one.